Hi, everyone. Really excited to have you. Welcome to our data center development series. And this is really the first episode in a series of in a three-part series. And we'll start on this topic of demystifying data center development. Today, we're really going to try to cut through a lot of the noise on why data centers are booming and other asset classes are maybe going a little bit slower, and really what development management means in this space as it relates to data centers. So, first, I want to do quick introductions. I'll introduce myself. I'm William Sankey. I'm the co-founder of Northspire. Northspire is a leading purpose-built platform for real estate developers and real estate owners. We were founded in 2017 with the intent of really bringing automation and data analytics and AI to real estate project delivery and really sort of this portfolio management. So teams can have just more repeatable, predictable outcomes on these mission critical complex projects like data centers. Also help teams, get away, especially high value talent, focus on strategic decision making instead of some of the low value administrative tasks. So I should mention, probably important to mention, I come from the traditional side of the real estate development industry. I spent a lot of time in New York running real estate projects, including, I like to say, I did get to help build out one on-premise data center, which is underneath Madison Square Garden, the arena. And I've learned a little bit about data centers in the time since then and worked on all types of other complex projects, multifamily, office, retail. And I'm really excited to be joined today by Emmanuel Daniel Alisonar. Emmanuel, why don't you introduce yourself?
Thank you so much, William. It's a pleasure to be on the call, and I'm absolutely excited to be able to participate and talking about demystifying data center development. With that, my name is Emmanuel Daniel. I am the principal and founder of Alusnar. Alusnar is a strategic advisory and consulting organization. I founded Alusnar with the principal goal of being able to design and build better data centers, focusing not only on hyperscale data centers, but also on edge data centers and how data centers will be able to serve us better, be more optimized, be more efficient, and how we could get these things running faster, quicker, and cheaper. And I'm looking forward to this conversation.
No, really exciting to have this conversation and to be sitting with an expert on this topic, especially at this moment in time where I think we're in this moment. I don't know if people would have expected this a few years ago, but we're in this cycle for a lot of data center development on really fueled by this persistent demand outstripping supply relating to artificial intelligence, which has really been this accelerant to what was already this gradually growing, existing like cloud trends that have been underway for 2 decades. I think high level in terms of state of the market, and I'll really let you get into this even more, man. You have structural low vacancy, especially in these primary markets. You got a lot of record construction for data centers. I guess I'm curious if you want to touch a little bit on where, you've been in this industry with some of the, people like Microsoft as a leader, one of the largest data center developers in the world. And you worked in the US as well as abroad in the Pacific region and the US. So you've done this globally, you've done this in the US. Now you're out on your with Alisonar, really like with a framework for how you execute on data center development more broadly. I guess I'm curious, what do you think about the state of the market and maybe what's different about this cycle versus prior cloud build outs and with things like AI and power constraints coming into play?
Great. No, thank you, William. And, just for context, that you said, I've served globally. I actually counted, and what I counted was I've worked across 31 countries, overseeing delivering projects. And till now, I've probably crossed over 200 projects executed and delivered across 31 countries. So it's been an exciting ride. And with that ride, a large portion of it has been with real estate. Started with commercial buildings, started with sustainability, started with campuses, cities, and now data centers. With data centers, William, I want to set the context up front that when people talk about development, the first thing that hits them is, oh, it's all about construction, it's all about pouring.
Mhm.
But when we talk about development management, it's a lot more. It involves orchestrating power, orchestrating capital, orchestrating risk, orchestrating ESG, and ensuring all of that works. And when you put that into a data center, it's also ensuring all of the assets in that data center are running and functioning the way they have been designed to run, right? And that's what makes it complex. The biggest challenge that people sometimes take for granted with data centers is data centers are precision systems that run to serve our needs, and our needs could be data, services, scrolling on your phone, watching a video. All that is backed by the enormous compute power that data centers have. And just in terms of volume of power, uh, I had this discussion a lot of times where I tell people that, how much of energy a data center takes up, and how much of energy you would have to have in case of an outage or a backup. By 2030, we are looking at 945 terawatt hours of electricity annually will be consumed by data centers. And to give context, what does that actually mean? That's the annual power usage of countries like Australia or Spain. You can imagine that's what data centers are going to consume if they have to be a country by themselves. In the US alone, 5% of all electricity demand is consumed by data centers, and that is expected to double by 2030. So now when you're talking about AI and you're talking about the cloud and all the digital services coming in, building then has become one of the most complex forms of infrastructure management. Look, everything is complex. Building a bridge, building a high-rise building, but because of the usage and the intended purpose, where data centers don't just serve the people in that building, they serve the population outside of the building. In fact, more of that, millions and millions of people will be fed through a single DC or a combination of, and they won't even know which DC is serving them. Hence, the orchestration of these projects, building them, constructing them, managing them, has become extremely complex, right? And that's where the market does. Why? When we started, we used to have a small scale DCs, right? We used to say, hey, what's the big deal in designing a server room? And in fact, there is no big deal in designing a server room, right? If you have a building, you take a portion of that building and say, here you go, have 10 racks, and all these 10 racks, place the servers in, bring them power, bring them cooling. If cooling is not sufficient, I'll bring a portable air conditioning unit, plug it in there, and I'll cool those racks. You can't do that today, because these machines are fine-tuned machines with extremely precision temperature control that is needed. Even power distribution, backup distribution, locating it have all become monumental challenges. So when we start talking about scale and we start talking about AI, the amount of power AI takes, your hyperscale facility averages today anywhere from 100 to 150 megawatts. The cost of construction per megawatt is anywhere from $7 to $10 million. Even a smaller edge site runs into 12 to 18 million per year, purely because per megawatt, because edge sites are urban, they have all the cost associated with it. So a single 50 megawatt data center consumes as much as electricity as 80,000 US homes. And the cost, well north of $400 million, $500 million to deliver this. This is why development management isn't about pouring concrete. It's about bringing all these elements together and working so that we are effectively able to manage it and deliver these essential services and components to power these essential services on time.
And Manuel, that was really informative. You said a lot of interesting things, and I think really underpinned by this. It sounds like this is a game about just as much about like guaranteed access to power as well as being able to build the infrastructure itself. But you mentioned a few things that maybe, since this is about demystifying data center development, might be helpful to dial in on. You mentioned hyperscale AI data centers. You use the word like edge data centers. Maybe we could just talk a little bit about like what the difference is and what two things are.
Yeah, sure. People talk about the cloud, right? Cloud is big and huge, floats above you, but in our particular case, a cloud is a large data center. That cloud, when it's really big, we're talking about, in terms of energy consumed or energy demand, anything over 100, over 50 megawatts, it was actually much smaller than before, is called a hyperscale data center. These are generally far away. They're located outside of dense urban locations. Why? Because you need a lot of land, you need a lot of power, you need access to water, and hence they're located in locations outside of cities, generally a couple of hours from a city. But at the same time, you have something called latency. Latency is when you need information right now. You need responses right now. For example, let's assume you have booked a ride on an autonomous taxi, right? And the cab comes in, picks you up, and has to make a decision where to turn and what to do. You wanted to make that decision almost instantly at the speed of light, rather than waiting for a couple of milliseconds for it to go and get it processed and to come back to you. To serve those needs, the need for edge data centers have started to come up. Edge data centers are smaller data centers, anywhere from 5 megawatts to 10 megawatts, maybe even smaller than that. The whole goal of these data centers is to be in dense locations close to the people so that it is able to give quicker, faster responses. Now, it doesn't mean because edge data centers are smaller, they are weaker or they are less efficiently designed. No. The purpose is to minimize latency. And that's why, with the growth of AI, the growth of autonomous systems, and the needs for what we are watching, it is important to have a combination of both. Smaller data centers, which are close to us, that will be able to drive demand responses quicker, and larger data centers farther away from us, which is able to take all the data that we want and drive higher intensity applications. Those are the two big classes that they're talking about. Now, in between, William, you also have mid-sized DCs, right? Because not everybody can build a 100 megawatt or 150 megawatt DC. Even you've actually heard about the OpenAI, where they are talking about building 1 gigawatt data campuses, right? And when you compare that with saying that, well, hold on, if 1 gigawatt, how much of energy is that? If 900 odd terawatts is the amount of energy a country consumes, where is that energy going to come from? How do we generate that energy? That's why it is important to have smaller DCs backed up by larger DCs, so we are able to connect, we're able to access. Just imagine, if you have kids today scrolling on and watching videos, and for every video they have to get glitchy, they have to wait for it. I mean, it would drive them nuts. And given that those are the future customers that would use the data services coming from the DCs, you have to create an experience where they think, wow, man, the cloud is phenomenal, I can get all my data right now. And that's made possible because we have edge DCs and we have hyperscale DCs interconnected and scattered out.
Mhm. No, that's a great like definition of these different types of data centers. 'Cause I think often people you might lump them all, but into one bucket. But the world really changed with the rise of these hyperscale data centers. And you mentioned not only is the location different,
Mhm.
but it's like access to water and power. And so I want to dive in a little bit more because I think some of the specialized knowledge, especially for maybe a real estate developer or a real estate owner that's looking to move into data center development. In traditional real estate, a lot of your expertise, whatever asset class you're working in, is around understanding the market for site selection, right? And I guess,
Yep.
like you mentioned, with these hyperscale data centers or edge data centers, which are more dense areas, there are often different things, considerations, whether it's access to power or I imagine fiber as part of the site feasibility analysis. Do you want to share a little bit about around your thoughts on just like how a developer should think about like what's the 101 notes on how they should think about site selection if they are getting into this space for the type of data centers you describe?
No, that's a great question, William. In fact, a large number of folks, okay, who come and tell me that, hey, I want to build a data center. The very first thing that I ask them is, okay, have you understood what the criteria is for choosing a site? And they say,
Mhm.
oh, we have hectares of land. I'm like, no, that's not the question. It has to be specific in terms of what you would like to achieve, right? And that's where we get into why site selection is so important. The biggest challenge, and we've heard this on the news, we've heard it from multiple folks, is power availability. You have grids in the US that are maxing out, and they're having a hard time in terms of providing the power data centers need. So when you are choosing a site, the very first question that has to be answered is, can I get sufficient power to that site? If I cannot get power from the grid, am I able to get alternate sources of power, which could be generators, which could be gas turbines, which could be batteries or some other forms of energy, right? So power availability. Next, as you correctly said, is fiber connectivity. You'd have heard recently in the news as well, there was an outage where the RFC cables got cut. And because these cables were cut, there was issues with respect to latency. So how much of connectivity can I have? Because ultimately connectivity is provided by carriers and by telcos. So the question or the thought that's going to come is, everybody needs a primary and a secondary, right? Even more than that. So do I have fiber connectivity to that location? Do I have available carriers that will be able to give me that connectivity? Third, it's going to be one of the most important things is going to be land and zoning. You just can't go and build data centers wherever you like them to build, right? You have rules, you have guidelines because you've got residential populations. You've got people that want to live there. You've got jobs that need to be created, right? Economic stimulus, economic developments. So land and zoning, which talks about size, setback requirements, industrial versus mixed use zoning, and the expansion potential. Next, water access. We have greatly advanced in terms of cooling technology for data centers. In fact, we have become more and more efficient, but that does not nullify the need for having access to water. So for cooling, how are you going to supply water? You have water bodies close by. Is there on-site supply? Is there municipal infrastructure or alternate types of coolings that you have to understand? Next, the most important one, a lot of people would have heard about flooding in data centers. A lot of people would have heard about fire at data centers because of lightning strikes or thunder strikes that would happen nearby. Now, risk and resilience, where what is the natural disaster exposure on that particular location? Flood, seismic, wildfire, okay, all these elements start to come in. And last, but I'll probably say one of the most important things, okay, is going to be permitting and incentives. Equally important, you need incentives because that is what attracts investors to come and build DCs there. You need to have permits done because so you ensure that the land and the usage of that land is protected and benefits it. So things like tax credits, utility rebates, special economic zones are key aspects of site selection. It's not just saying that, look, I have land, let's build a DC. It's like you have land and do you have all this? And now let's start talking about building a DC.
This is really informative because I think when I I mentioned I helped build a small on-premise data center probably I don't know 15 years ago
Right.
at this point, and there's a lot of focus on things like specialized cleaners, very different from typical development where anybody can come in with a mop and broom. There's a lot of focus on like air conditioning and HVAC, not so much on water. And I guess that was partly because, we probably weren't using that level of energy and the density of chips on these racks these days, which is creating so much heat that you need new types of cooling systems. Is that sort of why you have this sort of whole new world of expertise around cooling systems and access to water and all of that?
Yeah, that been a very interesting stat, William. Okay, everybody uses AI today, right? But people don't understand the energy intensity of AI. So, for example, training a single GPT scale AI model can consume as much as electricity in one run as around 120 US households in a year. So you compare that where you're building a small scale DC where conventionally we didn't have these power demands, we didn't have these power requirements, right? To now, today, where you have all that power coming in to manage all that power, to back up all that power. That's why the demands for data, the demands for computing power has forced us to move DCs out from rooms in a building or rooms on half a floor to large scale DCs that are able to satisfy the needs of compute that we conventionally have. Right? And we didn't deal with these constraints 10 years ago, right? All these constraints have started to come up now.
No, this is fascinating. I feel like we're in a whole new frontier, right? And I guess these are really important considerations for teams thinking about like, should I build data centers? How do I start? What site should I think about? At Northspire, one of the things we tend to work with teams, we work with hundreds of developers across the country, and most real estate developers and real estate teams are very focused around managing the flow of capital. They're focused on what is the budget and did I bring it in on budget? And I guess if you think about data center development and people that are not in that space today pivoting into this space, my understanding is there's quite a few things you need to think about differently about when you're budgeting. Say instead of an apartment building, which has a budget that might have 80 line items of things, architect, lighting designers. But I imagine when you're thinking about building out that budget for data center development, you're thinking about specialized infrastructure costs. Maybe you're thinking about like the technology and physical systems or security. Maybe you're also thinking about the partnerships and consultants like Alisonar that you need to work with to bring this level of expertise that most developers don't have in house. Maybe you could speak to a little bit about these different line item expenses that are critical parts to executing a data center development project that end up making the budget look very different.
Yeah, no, this is a great point, William. And this point has actually started to come up in a lot of discussions, uh, even in a lot of the earnings calls and earnings releases, because now everybody's building hyperscale DCs. The question that people are having is, well, hold on, if everybody is building them, who builds them better? Who is more profitable? Who is building them correctly, right? Because, it's like cars. Okay, everybody, you have different cars. But the question is, there are differences between an F1 car. There are differences between a family car. There are differences between a bus for large-scale public transport. And each has its purpose and need, right? When you are choosing a car, you choose it based on what needs you have. So when we are talking about providing cloud services, you have an intense way to provide the services as efficiently as possible. So I cannot go and have unlimited amounts of money to spend on building a DC. And this is where DC financial management for construction becomes extremely important, because ultimately everybody is going to ask you the question, hey, how much does it cost you to build? And based on the cost of building it, how much is your cost of service, and what is your operational profits coming out of it, right? Is it viable? Because if I'm going to spend too much and my construction costs will run away, my service will not be profitable, right? Hence, I need to balance it. That's why the intense scrutiny now on financial management of data center development. The biggest cost where we have to deal with is going to be the true cost visibility. A lot of people will discount the land, but you have a land acquisition cost, right? How am I accounting for land acquisition cost? How am I accounting for construction cost? How am I able to break down that cost per megawatt? Some of the stats that I gave earlier, where I said 7 to 10 million, is the cost of construction per megawatt. How do I track cost of construction per megawatt, right? It is very different from commercial buildings where we have different ways of measuring it. Next is the aspect of being able to understand direct costs of items to the capacity delivered. So what does that mean? I've got cost of electricity. I've got cost of cooling energy. I've got cost of facility maintenance and spare parts. I've got costs of carrier interconnections, right? How am I going to be connected with different carriers and telcos that I'm working with? I also have to deal with IT costs. IT cost, as you know, William, the pace at which technology changes, the pace at which these AI chips are coming out, and the technology obsolescence that occurs, right? I've got to take care of depreciation of all of my IT assets and all of the critical asset that comes in as well. Now, so in addition to that, I also have to be extremely focused on cost overruns, where power interconnection delays are a big problem as it leads to cost overruns. Second is scope creep. When you're talking about a data center, you always talk about the tiers of a data center, and that basically talks about tier 1, tier 2, tier 3, which basically talks about, hey, the redundancy factor in it. So I can have an N+1 data center, or I can have a 2N data center, but I'm going to mirror everything. Now, while accounting for this, all of a sudden it's like saying, well, hold on, this has to be a 2N data center. But I thought you just wanted a data center. You're like, yeah, I want a data center that's 2N. They're like, oh, but we didn't put it, right? And that shocks a lot of the developers, because you generally have to don't provision for this in commercial development, right? Like we conventionally would have to do. Your supply chain risks, right? You just can't go and buy a transformer or a switchgear. Because of the demand this has started to put in, it has led to a backlog. So planning your construction cycle, your cash flow for your construction management tied to asset delivery is going to be critical. It's the some people do, why can't I go to Home Depot? Like, you could, but I doubt you'd find anything that you'd want there as it pertains to transformers, switch gears, and chillers for these large scale DCs. Then expectations. How are you able to deal with changes that will occur, and why? And these changes is not something that these changes don't happen. The rate and pace at which these changes are coming in. For example, I would have decided to have a data center that offers bare metal services. All of a sudden, because data center construction takes a couple of months, we then get a signal to say, well, actually, given the state of our services, I think we need to add more AI services in there. And you're like, oh, well, sure. But then all of a sudden, AI services, to give you an equation, when you're talking about conventional server power consumption, 10 to 15 kilowatts per server, and okay, all of a sudden you're talking about AI workloads, right? Where in excess of 30 kilowatts. In fact, if you look at Open Compute's latest designs that was published out, the new power consumption per rack can go up to 1 megawatt as well, right? So that's the insane amount of power a rack would take. Now, if you're coming and saying, hey, let's have AI racks in there. You're like, yeah, but we didn't cater for the power. Now to go and get more power, I got to go and put a request in. I don't have all this. I didn't have to balance it out. So you see, all these aspects are multiple unknowns, and these are very large unknowns. So even though we don't spend a lot of time aesthetically designing the facade of a data center, we spend a lot of time managing the guts of that data center. And that's where all these aspects takes extreme precedence. So rigorous program management aligned with design, procurement, contingency management, because you have cost overruns, you have equipment shortages. We all remember the chip shortage that occurred a few years ago, right, where we couldn't get anything done. You have commissioning that you have to take care of. You have to work with vendors and OEMs. So all these challenges, multiple stakeholders, multiple roles, multiple cost elements, multiple avenues for cost overruns and design changes is what makes data center development complex. And these complexities generally are not encountered in a commercial development project. So when you have someone who's never done it before and you have to do that, oh, hold on, why am I responsible for this? Why do I need to take care of this, right? That's where, we say that the shock hits you, it's like taking a cold plunge. You freeze for the first couple of seconds and they're like, oh, okay, cool. Let me sink into it.
Mhm. No, that's all super interesting because I mean, I imagine, if you're a real estate developer, you're thinking about some of these things, but often you're not working to that level where you're, usually technology infrastructure, unless you're working on things like already industrial, development where you might have some of those type of challenges, but you're usually, you don't have that level of internal expertise. And so I imagine that at Allison R, I imagine you're probably hearing from a lot of people that probably are really tapping into you guys, the many years of experience you guys have built building what you mentioned. I think you described over 200 data center projects, which is sort of incredible across the world, right?
Yeah. The first question that I get, William, when we are talking to potential data center developers and owners is, one, how do we start? Two is, what should we consider? Once again, these are folks, access to capital is one thing, and I don't think they need our help when it comes to acquiring capital. How that capital is going to be managed and dispersed efficiently so that they can get that data center delivered on time, on budget, is where they come to Alosana and say, hey, how do we do it? What should we manage? What should we look at? How do we avoid these cost overruns? How do we avoid these design changes? And why should we look at it? How are we able to set price contracts up front? How do we work with the grid in terms of how much of energy we need to provision for? This is where we really help them. And then when they start seeing the whole picture, they're like, oh, wow. So I need to plan and I need to take care of all these things and need to budget for it, is where they then start to understand the complexities of data center development.
I mean, I think that's such a good pivot point. And maybe that means, like, for the first part, I know this is a 3-part series. We wanted to demystify things a little bit on this call. Our next webinar, we really want to dive a little bit deeper into breaking into data center development. So I think that's actually a really good pivot point. And I would say, maybe I would close by saying, because as you were talking a little bit about some of the specialized tracking and managing capital across all of these vendors and infrastructure deployment. I came from the traditional side of the real estate development industries. I worked on different types of projects, offices, sports arenas. When I co-founded Northwire, I wanted to really make sure our tool was purpose built for how a real estate team thought about executing projects, not just from the perspective of like a general contractor, but really real estate owners that have capital partners, that have funding requests, alongside like managing all the things like soft cost consultants and contractors, investors, all of that picture, right? And that's where historically Northfire has come in, and we worked across all asset classes, including, we have a lot of data center developers that we work with, and one thing I start to observe as we work with some of the data center developers is they have some very unique, different challenges around how do you track. And I think you mentioned, right, like things like benchmarking by kilowatt and megawatt, like and reporting on those types of metrics, or even things like having a data center underwriting model. And those are things we've been really responsive to. I think we've I think we're one of, we've been purpose built for real estate owners and teams, but we really leaned in to have a lot of purpose built, unique like language and metrics and even like underwriting model for data center developers. So I'm really excited to go deeper into this conversation with
Right.
you, Daniel. And thanks for what was very informative and very demystifying about data center development from one of the foremost experts in the industry. So thank you for taking the time. I enjoyed the conversation.
Thank you so much, William. Absolutely loved it. Thank you so much for the opportunity.